Yeah, this is my slide. Good afternoon. My name is Huang from NOAA CIRES, CU CIRES and NOAA GSR Lab. And today I'd like to use the opportunity to talk about our aerosol data assimilation development within JEDI for UFS model. So you can see this is a collaborative effort across universities, NOAA research labs, operational centers, GCSDA, and yes, that's all. So today I'm going to start with a quick introduction of our initial aerosol data assimilation development for GAPS aerosol model and its near real-time evaluation. Then I'm going to present our recent extension of this JEDI-based 3D MR aerosol data assimilation system for NOAA's future operational UFS aerosol model. Lastly, I'm going to highlight our ongoing collaborations to enhance this JEDI-based aerosol assimilation system. The first part of this work is funded by NOAA WPO and the CPO program, and these two projects were completed already. So the global ensemble forecast system aerosol GAPS aerosol went operational to provide global aerosol forecasting since September 2020 at NOAA. Its aerosol module is based on NASA's go-kart model with 15 aerosol tracers, including dust in 5 size bins, sea salt in 5 size bins, total organic and black carbon in 2 size bins, and also sulfate aerosols. The most common aerosol observation is a 2D column integral aerosol optical depth AOD. It represents the total extinction of solar or lunar radiation by aerosols over an atmospheric column. So the animation at the bottom shows an example of the coverage of NOAA's 550 nanometer AOD retrievals in a 6-hour data assimilation window. Currently, several operational and research communities have been running near real-time AOD assimilation for aerosol forecasting and producing aerosol reanalysis, such as UFS, NASA, US Navy, GMA, and recently at our lab, GSL. In our AOD assimilation, all 15 aerosol species will be used to simulate AOD, and then an AOD increment will be calculated to further adjust the aerosol species. Next one. This is the flowchart of our system. It is built upon the ensemble variational framework within JEDI. Besides that, in the ensemble forecasting step, we further scaled and stochastic perturbed aerosol emissions. It was meant to better account for the aerosol emission uncertainty and further improve the performance of the AOD assimilation. And we have this work summary published at GEMS. If you're interested, you may refer to this paper. And since October 2021, we have been using this system to run the near real-time VRS AOD assimilation at our lab. And we have 2 parallel runs. The first one is free run without AOD assimilation. The second one is LDA. It runs 6-hour assimilation of NOAA VRS 550 nanometer AOD retrievals. Again, in our ensemble forecast step, the aerosol emissions are skewed and stochastic perturbed. And also in our near real-time run, we are using the GSL's intermediate CCPP-based GAPS aerosol model, while the operational GAPS aerosol model is based on the new ops interface. But we believe that the DA impact derived from the CCPP version should apply to its new ops version as well. And we also displayed our near real-time results at the GSL website. And here we compared with AeroNet AOD, NOAA VIRS, and NASA MODIS AOD, and the near real-time AOD analysis from NASA GOES, NASA JUICE, and UFS CAMS model. In the interest of time, I will only show the verification against NASA's AeroNet AOD in 2 months, like December 2022 and June 2023 in the top panel and the bottom panel, respectively. And NASA's AeroNet provide very high quality AOD. It's normally used as ground truth for aerosol verification in our community. So you can see here in blue, and compared to the free run 6-hour forecast in blue, the LDA 6-hour forecast in green, and the LD analysis in red. You see the LDA has a much better agreement with AeroNet AOD compared to the free run 6-hour forecast. And recently, we extend this JEDI-based 3D MR aerosol assimilation system for NOAA's future operational UFS aerosol model. This work is funded by NOAA WPO and the GSL DDR funding, and partially by UFS R2O Advanced Compilation Project. So as you may know that a collaborative effort has been ongoing at NOAA to planning to integrate global prediction within the UFS model. Here we call it UFS aerosols. Compared to GAPS aerosol, UFS aerosol adopts updated version of go-kart model, and a detailed comparison between the UFS aerosol model and the GAPS aerosol model was given at in my colleague's talk at AMS. So here, what matters to our AOD assimilation is that the new model will include additional natural aerosol species in 3 size bins, as shown in the animation in the bottom. And to accommodate this change, we extend the AOD forward operator and extended linear and adjunct model in JEDI UFO. It means that when we're calculating in the forward model, we will calculating the AOD. We will consider the contribution from the natural aerosol species, and in return, the resulting AOD increment will be also used to adjust natural aerosol species as well. All the development has been merged to JEDI's internal repository, and hopefully it will eventually become public available through JEDI's future releases. Here, we run 1 month sampling experiment to evaluate this new development in October 2027. And still we have two runs, the free run and LDA. In the LDA experiment, the aerosol emissions are not skewed or perturbed yet. We are working on that. Hopefully it will be done very quickly. And the animations here compares the free run and LDA against the VS AOD retrievals. So you can see that the LDA actually fits the VS AOD much better, suggesting that our developments works as expected. And here we compared our UFS aerosol AOD with Aeronet AOD, the top panel. And here we also include the CCPP-based GAPS aerosol run. I mean, this is not apple-to-apple comparison between these two model run because they have different configurations, and also they are covered different, they are all October, but at different years. But consistently, we can see the LD assimilating AOD in LDA shows positive impact in both model runs. And here we also compared our UFS aerosol analysis against AOD reanalysis from NASA Mero 2 and uses CAMS-RA. So the top panel shows the monthly average AOD in Mero 2 and CAMS-RA, and the lower two panels shows the bias of the free run 6-hour forecast and LD analysis. So you can see the LD analysis actually shows smaller bias compared to free run, except I'm not sure how to use it. Except over North Africa, you can see that LDA analysis actually shows a larger negative bias. But we found it's because we are assimilating different AOD retrievals in our analysis and also the reanalysis from NASA and E7WF. In our AOD analysis, we assimilate NOAA's VS AOD retrievals. However, in the reanalysis from NASA and E7WF, they assimilate NASA's MODIS AOD. So as you can see in the bar plot over North Africa region, which is enclosed by this green circle, you can see the NASA's MODIS AOD is much higher than NOAA's VS AOD. As a result, our AOD analysis is will have a larger negative bias when we compare with the reanalysis from NASA and E7WF. So this is also raised the uncertainty from the observation perspective in the aerosol data assimilation. And next, I'm going to spend some time talking about our ongoing collaborations attempting to further enhance this JEDI-based aerosol data assimilation system. As you may realize, in all the diagnostics I showed in the previous slides is all performed in terms of AOD, not specific aerosol species. It is because assimilating the integral AOD retrievals at a single wavelength is not able to properly constrain in the 3D aerosol species in the model. So as you can see here, the 3 profiles gives you can see the profiles for dust and also organic carbonaceous aerosols are very different in our analysis in red, and in NASA's reanalysis in black, and in EC's reanalysis in gray. This large uncertainty make it very difficult to understand aerosol's relative impact in the model. But we have opportunities. So in our current project, we are gonna in our upcoming project, we are gonna collaborate with aerosol experts from NASA, UMBC, and so on to assimilate NASA's next generation based aerosol retrievals to further including multi-wavelength AOD retrievals, fine mode fraction of AOD, single scattering albedo. Simultaneously assimilating all these AOD retrievals is expected to further improve the aerosol representation in UFS aerosol model, such as aerosol composition, physical and absorption properties. And this work was is funded by NOAA CPO program. And also in most of the AOD assimilation system, they are assimilating the daytime AOD. This can be a problem, especially for the global AOD assimilation system. For example, the resulting analysis may not be able to better capture the aerosol diurnal variational features because of missing the nighttime AOD retrievals. To improve over this, we're going to collaborate with University of Iowa to assimilate lunar time, nighttime AOD derived from various moonlight observations. And our preliminary results shows that assimilating complementary nighttime AOD provide additional information here. And lastly, beyond the observations, we also need to further address the inherent deficiencies in our current aerosol assimilation. Otherwise, it will not be able to make full use of the observation information here. So first, we would like to deal with the non-Gaussian of the distributions of AOD. To do this, we plan to assimilate the log transform of the AOD, which better satisfy the Gaussian assumption, Gaussian distributions, which is assumed in our current EMBAR update and the NKF update. So it should be able to further improve the AOD assimilation performance. And the second, as I mentioned earlier, our aerosol system, data assimilation system is an ensemble-based system. Even though we already perturbed aerosol emissions, however, its spread is still far from sufficient. So, okay, thank you. We're going to develop some stochastic parameterizations to further improve the ensemble spread. And lastly, we also need to address the uncertainties related to observations and also aerosol models. And all the proposed tasks here, we plan to implement them within JEDI, and hopefully they will be accepted and eventually become public available. That's my last slide. Thanks for listening.
Thank you very much. Are there any questions for Bill?
Well, great work. And also thank you for showing these uncertainties in the AOD data.
Yes.
We have to deal with, always we have this challenge, especially with the satellite AOD. Now, what do you think about assimilating the surface PM2.5, which can help us to improve air quality forecasting?
I mean, this is a global data assimilation. So right now, AOD is the most common observation we're going to assimilate in the global data assimilation. So I would say assimilating PM2.5 will help to further improve the model. But the data is very local, so we are not sure how it will impact in the global context. It would be, if in the region data assimilation, it should have very obvious impact, but for its impact in the global model remains to be investigated. Thank you.
Thank you. So we'll have to move on now to the next talk by Barry Baker.